Welcome you all to the week 2 tutorial of the differential equation for engineers. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. In this tutorial, we are going to do some illustration that are based on non-exact equation, Bernoulli equation, and second order ordinary differential equation and their properties. So let me just start with the first question. Solve x into 1 minus x square dy plus x square y dx2 dx 0. We have given a, can say, first order linear differential equation and we need to find out its solution. From the previous lecture we have learned some method that are as follows. Exact equation solving method. We have learned homogeneous method and separable form method. So here we need to see that what method we can apply. So if you see the lectures of this week 2, you are getting a feeling that you may try this one to make it the form like this. This is general first order linear ordinary differential equation form. So if we will try to write our equation into this form, so this is our given equation. So if you will observe, so you may write this one as y dx and the factor on the right side it will be like this. So this will give you 2x square minus 1 divided by ax cube. So it is easy to see that now we wrote our given differential equation into the standard form, so we can compare and can get px is equal to x square minus 1 divided by this one, and qx will be nothing but ax cube divided by x into 1 minus x square. Now we need to follow up this with this px and qx, and we need to find out the solution. So try this one and I'll let you know. So Abhishek, I'm repeating again that till now we just wrote this question and we tried to convert this equation into the standard linear ordinary differential equation, and we got this px and qx, and now you have to follow the approach how to solve that this linear ordinary differential equation standard one form. Try this one. So let me start with recalling that how to solve the standard equation. You know from the lectures that integrating factor, I would say this name star and equation name. So for star, you know that integrating factor is nothing but e to the power x dx. While solution of star will be y into integrating factor will be qx integrating factor dx plus some constant. Or you may also write like this, that if we assume that there is a constant, we are integrating the definite integral form x naught to x dt dt, where x naught is any point from the mean, then solution will be this into x. So x naught to x q s fact respect. So this is our general. So here our px is 2x square minus 1 divided by x into 1 minus x square. So first of all we will calculate this px. So this is 2x square minus 1 x into minus x square dx. From here you can apply the partial fraction form. So but I would go with another method that is quite visible also. If you will rewrite it as in this form, then we'll get to know that this will be nothing but x by 1 minus x square dx plus, in fact, with the negative sign, it would be dx by x. Now clearly the numerator is nothing but the differentiation of the denominator. So if you will multiply and divide with this minus 2x, so this will be dx minus dx by x. So from here you can also decide the domain, since you are dividing this with x and 1 minus x square. So domain must not contain 0, 1, minus 1. So we need to take care of this. This will give you ln 1 minus x square minus ln. So if you will rewrite it, this will be ln 1 by x under root 1 minus x square. So this will be your integrating factor. Actually not integrating factor, this is the integral dx dx, and here there is also a constant c, but for simplicity, since integrating factor can be dependent on anything, or you can say for the time being we will keep it at as some c, then I will let you know what value we are going to assume for this c. So for the time being, let it c1. So this will give you e to the power ln 1 by x under root 1 minus x square, or e to the power c1. Now this e to the power c1, we'll keep it as it is, and the other factor will be x divided by under root x. Now integrating factor can be any multiple of this particular part. Therefore, for as usual simplicity, we avoid this constant, or you can say we say this e to the power cn will be nothing but 1. Okay, so our simplest integrating factor will be 1 by x under root 1 minus x2. This is our integrating factor. Now from the solution of y into integrating factor, that is x under root 1 minus x square, and what is our qx? Our qx is a x cube divided by x into 1 minus x square. This will be x into under root 1 minus x square dx. Now we need to solve this only. So for this, 1 minus x square, a will come out, and from this 2 power of x will be cancelled out, and it will be 1 minus x square 3 by 2 dx. So what we will do, we will divide and multiply with this minus 2. So this will be 3 by 2 dx. So here, since it is the numerator is the differentiation of the term this 1 minus x square, so what we can say, we can directly assume that if 1 minus x square is t, then it will be the minus 2x will be the differentiation of this t, that is dt. So I am directly writing that 1 minus x square minus 3 by 2 plus 1 divided by minus 3 by 2. If you are not getting anything, then please let me know. So this will give you minus half. So this will be a divided by under root 1 minus x square plus this c2. So or I can write c. This will be the solution. So if you will rearrange it, you will get ex plus cx times under root 1 minus x2. So this will be the general solution of the given question. So I am mentioning one note here that if you are not getting any point, you can ask me. So I hope this question is easy, so and it is clear to everybody. I'm writing the next question. Second one is solve y ln y dx plus x minus ln y dy. Try this one, then we will discuss it. I'm giving you a hint of this question. So this is similar to the question number one. So in the question number one, we standardize our differential equation into the first order linear differential equation. So in the same way you have to do for this question, but there is a little key point that in the first question we convert we treat y as a dependent variable and x as an independent variable. Here you need to treat x as a dependent variable and y as an independent variable. Then it will be easy to solve, or you can convert into the standard form. Right. So let me form standard respect to y treating x as dependent variable. We may write it y ln y dx plus x times dy is ln y dy. So next one will be plus x by ln y. There will be no dy now. There will be 1 by y. So from here you can observe that dy will be y x by y ln y, and qy will be 1 by, so integration dy dy will give you, so since this ln differentiation of ln y will be nothing but 1 by y, so this will be like dt by ln dt by t, so ln t where t is ln y. So I wrote it directly. Again, c is a constant, so for simplicity we will not write c. So the integrating factor will be e to the power this integration y dy, which will give you e to the ln y, which will be, so solution for the given differential equation in x into this integration factor qy, the integrating factor is some constant. So you may write this constant after the solving the integration. So this will be x into ln y integration. So what was our qy? 1 by y. So this will be ln y dy. So this integration is dy. This will give you x ln y. Now observe again, ln y, treat ln y as some z, and 1 by y dy will be its differentiation. So this integration converted into integration z dz. Therefore this will be nothing but divide by 2 c. So you will rewrite this one. So 2 c. So this will be general solution solution. Okay. So I'm again telling you this y results ln y a will be z is ln y z, then dy z. So this will give z square. So see that I have done. So this is your general solution of this particular differential equation. Now the next question is like this: solve initial value problem dy dx is equal to x plus x and add to 2. So we have given a differential equation as well as the initial condition at x equal to 1, and here clearly it has been observable that y is the dependent variable. So we need to solve this initial value problem, and it is quite clear that it has been already given in the standard linear differential equation. We just need to rearrange in some manner and solve it in the, as per the question number 1. So try this one. So did anyone get anything? So let me again mention that, so we know that this is generalized standard form. So here this is 2 by x y, so dx will be minus 2 by x, dx will be x, or integrating factor will be e to the power plus dx dx. So we'll get by x dx, which will be minus 2 times of ln. So this will give you ln x square plus ln x to the power n into x. So this will be ln x square. And from here, we also observe that our domain must not contain x equal to 0. So we need to solve this differential equation over such domain where x equal to 0 has been excluded. So our solution will be y into 1 by x square equal to qx is x. So x into the integrating factor dx. So this will give 5 by x square integration dx by x. So this will give ln x some constant. Since you have given that y1 is equal to 2, so we will put this value in this solution to calculate the value of this constant. So this will give 2 by n square ln 1 plus c. ln 1 is 0, that means c will be. So the answer will be 5 by x square is equal to ln 1 x is 2, will be ln, or you may write it like this, 2 plus ln mod x into x square. So this will be your solution of the IVP. So basically I am writing unique because we calculated the value of the arbitrary constant. Unique solution of the given IVP. IVP means initial value problem. Since we have given the initial condition, that's why I'm calling it initial value problem. So I hope it is clear to everyone. So the next one is question number 4. Solve x ln y equal to y square ln y square. So we have given this differential equation. So it is obviously clear that this is not the standard form. So, or I think you can also observe that this is, you can also not make it into the standard form directly. So this is a different kind of specialized form, you can say, that is Bernoulli differential equation. So I have given you the hint that the given equation is the Bernoulli differential equation. Now it is easy to convert into the standard linear differential equation. So try to convert it and solve it. Then we'll discuss. So did you anything? Okay, let me mention. So it is observable that we need to convert this Bernoulli equation into the standard linear ordinary differential equation. So for that, what we will do, we will rewrite this. If you observe from the standard form, standard px. So this is itself giving you the hint that right hand side must be free of the variable y. Therefore, rewrite as y ln y whole square plus, and this will come as 1 by x into 1 by ln y is equal to square. Now if you will put 1 by ln y some new variable z, you will get that minus 1 by ln y square by the chain rule, the differentiation of y by dx is equal to dz by we get this quantity. If you will observe, if you will remove the negative sign from this earlier equality, then you will get the highest term of this differential equation. So 1 by y ln y square dy by dx will minus dz by dx. So our differential equation number 1 will become dz by dx with negative sign plus z by x equal to 1 by square. So dz by dx minus 1 by z square. So standard form, and this integrating factor will be e to the power px dx, and dx is minus 1 by x. So this will give you minus ln of x. So here also you can observe that y should not be 0 and y also negative. So that y is clearly positive. Moreover, x should not be 0. So this will be then by x. Therefore, solution will be, since we are solving this equation now, equation number 2, the solution will be z into this integrating factor 1 by x, integration of this qx, that is 1 by x square, into the integrating factor by x. This will be 1 by x cube, x to the power minus 3 plus 1, minus 3 plus 1 plus some constant, which will give you z by x is equal to minus 1 by 2x square plus c. Now z will be x plus c. If you will solve a little, so cx, this will give cx square minus 1 is 2x. And what was the value of z? Z was 1 by ln y. So 1 by ln y will be 2x. So from here ln y will be 2x by 2cx square minus 1, and y will be e to the power x divided by, or if I may write for simpler way, y will be exponential of 2x divided by 2cx square minus 1. So this will be the general solution of the given Bernoulli's differential. I hope it is clear to everybody. So let me write this one. 5. So solve x cube dy x minus square root cos x. This question is also similar to the last one. So try this one. This is again a Bernoulli form, such some kind. We need to convert into the standard linear. So try this one. So I would like to mention here, I think there is some typo. So negative sign, this will be negative, this will be negative, negative, and this will be positive. This will be happens sometimes, like solving this calculation. You need to be careful. So let us start discussing this one. As I told you that general form of this differential equation dy by x times y is equal to x. So if you will observe here that this term contains y, therefore you need it itself giving you a hint that you need to remove this term, or you can say you need to remove this y from this term. So if you will remove it, so you need to divide this whole equation by this y to the power 4 and by x to the power 3 also. So this will give you minus 1 by x by q is equal to minus cos x divided by q. Again, x cannot be 0, in fact y cannot be 0. Now it is clear that we need to put minus by q is equal to some z. This will give you 3 by 2 by x is equal to, so like that this d by x will be um, 3 dz dx. So your expression will be converted into by 3 dz plus 2 by x z x cube. So if you simplify, this will give 3x cube. So screen is visible. So it is visible. Sorry. So came to the standard form. Now what we have here is integrating factor will be e to the power integration of this px dx. Now what is this px here? Is 3 by x, which will give you 3 times ln, that is ln cube. So I am assuming that x is positive, or our domain is containing all the positive elements x. So solution will be z into this integrating factor integration of this qx into the getting factor, that is x cube dx. This will give you zx cube, and this will be minus 3 x dx. So zx cube minus 3 sin x plus c. So I hope till now we have verified. So it's correct till now. Minus. So now what will you get? Minus 3 sin x plus c divided by this x. And what was the value of z that we have assumed? We have assumed z to be minus 1 by y cube. So this will give you minus 1 by y cube, give you c minus 3 sin x divided by x cube, which will provide you y cube to be x cube divided by 3 sin x minus c, and simplification cube will be 3 sin x minus c. This will be your general general solution of the given solution. Okay, so till now we have done some illustration that are based on directly first order standard differential equation, ordinary differential equation, and Bernoulli equation. Now the next question is related to the property of this second order ODE, or you can say Wronskian. So let me write the second question. Next question number 6. Define Wronskian W by 1 by 2 for any functions and precisely two differentiable functions y1 and y2. This is our first task, and this y1 and y2 is defined, let's say, differentiable in interval AB. So the natural question arises, why we have taken this open interval? So the answer is obvious, that we can guarantee about the differentiability only inside this interval. We can never be guaranteed at this endpoints of this interval, that is A or B. The next task is to show that this W, Y1 and Y2 0 if Y1 and Y2 are linearly dependent. So you have learned from the lecture the definition of Wronskian, and also you are aware about this what is the meaning of this linear dependency. So try this one. So let me write the precise definition of this question. For any functions, just one thing, differentiable y1 y2 on the Chomsky y is y y1 is equal to x x y1 is derivative to its derivative. Okay. So this is the definition of this Wronskian for any differentiable function y1 on the one interval AB. Now the next question says that we need to prove that for any linearly dependent functions, its Wronskian will be 0. So let y1 and y2 are dependent. So what is linearly dependent means? There exists constant c that is not key such that y1x can be written as c times of y2. This is the definition of the linear dependency. So using this, if you try to calculate Wronskian of w y1 y2, then y1 value will be c y2x. This is y2x, and this will be c y2 dash x and y2 dash x. Now to calculate, this will be y2x y2 dash x minus c y2x y2 dash x. So this will be 0. We need to show this. Now here the natural question arises that we have proved that when y1 and y2 are linearly dependent, then we are able to guarantee that its Wronskian is 0. Can we say that Wronskian is 0? Then can we guarantee the y1 y2 are linearly dependent? That means converse. So I am putting the question: is the converse true? This is my question. If I would write it properly, means w y1 y2 is 0, it will imply that y1 and y2 are linearly dependent. Okay, so the answer is no. There exist functions for which Wronskian is 0, but they are linearly dependent. Try with this one, that y1x is some x square and y2x is x mod x, and I am taking x from Dylan. Try this one. Try to prove that its Wronskian is 0, but still these two are linearly dependent. So if you will divide sub cases, that is suppose if x, one case one is if x is positive, or you can say non-negative, then clearly you will get that y1x is nothing but one time multiple of y2x, and moreover to that, for all of this you shall calculate its Wronskian. So Wronskian of y1 y2 is equal to x square x mod x. This is 2x, and this will give what this will give me. So since x can be positive, x can be negative, so the cases will be divided. So from here, scenario, the Wronskian will x square 2x, and this is 0. So Wronskian is 0, as well as the vectors are linearly dependent. So we cannot claim from this case. What about case 2? If x is negative, then again y1x can be written as minus 1 times of y2x, linearly dependent, and calculate its Wronskian of y1 y2, this will be again 0. But can you comment in general, since there are two functions, so we can see that existence of a constant, non-zero constant, such that y1x can be the multiple of k times of y2x to show the linearly dependency. So can so this is my question. Can we say that y1x is equal to c times of y2x, where c is any non-zero constant? Can we say this? So the answer is no, because x square cannot be written as c times of mod x mod x for any c. Okay, so that means cannot guarantee this. But why? If you will try to calculate its Wronskins will come out to be 0. Therefore, the converse part is not true. If you will observe from here also, I just mention here, so this will give you 2 times of mod of x. You can write it. So this will give 2x square mod x minus x square mod x to 0. Because you can guarantee over this interval positive and negative, so it will be nothing but 2 times of mod of x. So in general, Wronskian is 0, but these two functions are aligned, linearly independent. Therefore, it is true that the converse of this statement is not. So we mentioned the next question. Question number 7. So in this question, find general solution of second order differential equation x minus y double dash x y dash x y equal to 0, knowing that a polynomial is a solution. So this particular question is based on the approach that we are aware about one of the solution, and we try to calculate its second solution with the help of this first solution, and as well as with the help of Wronskian of this these two solutions. So we need to guess that what is the exact polynomial which satisfy this equation. Then we can apply the approach that we have learned from the lecture. So try this one, like try first that which polynomial satisfies this differential equation. Then only you can get to the another solution. So let us first find out that with the hit and trial method, what can be the solution of this given second order differential equation. So let y1 x is equal. We will try to get the solution simplest one first of all. Try to hit and trial with this method. So if y1 x is equal to x, y1 dash x will be 1 and y1 double dash x will be 0. So put this value in this equation, one left hand side. So left hand side you will put and it will satisfy, then this will be our first solution. Then with the help of the formula we can get the second solution. X minus 1 into 0, this is our first term, minus x into 1, this will be our second term, plus x. So this will give you 0 minus x plus x 0, that is answers. So this has been satisfied. Therefore y1 x is equal to x is 1 solution. So if I would try to write the given differential equation, and since it is only one function, then we can say that it is independent also. So this will be independent. Since the order of the ODE given ODE is 2, so there must exist two linearly independent solution, and we need to find out the other linearly independent solution with the help of this y1 and this Abel's formula. So to judge with this Abel's formula, we need to rewrite this equation 1 like this: y double dash plus, sorry, it was minus, so minus x by x minus 1 y dash equal to minus y x. So this is think no, this, so this is your standard form, and from here you can see that x cannot. So now what is in general x y dash x q x y 0, and Abel's formula is w x power minus dx. This is our Abel's formula. So, and what is the solution of how can find out this y2x for this differential equation? So let me first write this one as per the lecture notation to avoid the notation ambiguity. P this is our Abel's formula. This next second independent solution we found with the help of like x is equal to w x. I'm writing w x. This means w at x naught. Okay, so that reason y1x e to the power, so integration x naught 1 by y s square to the power minus x naught to s e t e and whole integration with respect to x. So we have here two integrals to solve. So first of all, value of y1x was x, value of et is minus x by x minus 1. So try to solve this and get the value of this y2. So you know the formula of this y2, how to solve it, and you know the value of et, you know the value of y1x. Try to get the value of y2, and the linear combination of this y1 and y2 will be the solution of the given differential.
Sir, is Abel formula is a special type of formula?
If you have observed from the lectures that Abel's formula has been, you can find out from the solution of the differential equation. So we are taking its help because we know that y about y1x and how we can find out this y2x. Otherwise, there are some different approaches where you can find out the y1 y2 and you can calculate this also. So I must say that this is not some kind of different formula. This came out from the theory of this second order differential equation. You can see this, I can tell you the lecture number 11. In the lecture number 10 and 11, this has been told clearly. Okay.
Okay.
So you get y2x in the simplest form. Okay. Let me. So first of all, we will simply solve this factor minus 1 change to it's not this. This will give, if you will add and subtract 1 from the numerator, each factor will be 1, second factor will be, so this will give you x naught s, this will give you minus s minus 1 by s minus 1 and plus x naught. Okay, we will treat this as some c1, so it will be c, second term, so e ln x naught s, so minus s ln s minus 1 with the positive sign, x naught plus ln x naught is 1. So let us see some constant c1. What is this factor? E to the power minus x naught to x ds dx. This will give you power minus x naught s dt dt. So this will come out to be s minus ln s minus 1 to e to the c1. C1 will be assumed to be the sum C2, and this will come out to be e to the power minus s divided by s minus 1. ln with negatives, ln is with negative sign, so it will be s minus 1 will be changed to 1 by s minus 1. Now you have solved this first this one term. Now we need to solve this x naught to x integration 1 by y1 x square. So what is y1s? Y1s was s x only, so here it will be s. So x naught to x y1 of s, its whole square e to the power pt pt and this dx. This will give you c2 x naught x 1 by s square e to the power minus s divided by s minus 1 dx. So now you need to solve this one. So how can we solve this one? Any idea?
No, sir.
So if you will observe here that we made some calculation error. If you are able to find out that, then you will be able to integrate this one. And that error has been done intentionally. See, first of all we have calculated this one, okay, then we need to multiply with this negative sign, and here I have not multiplied with this negative sign, so this will be my positive positive and this will be correct. So this will be come out to be not denominator, will be s minus 1 e to the power s. Okay, so if this is s minus 1, so this numerator will be s minus 1. Now can you get some idea? If you will rewrite it, x naught to x 1 by s minus 1 by s square power. One of the approaches that this is some function f of s and this is its differentiation. So we know the direct integration. Other approach is to apply this simplest eyelid rule. I hope you are aware about this eyelid rule. In first preference for the integration as will be given to this integration, then this logarithmic, this algebra, then trigonometric, then exponential. Okay, so from here, since algebraic term will come first, so we will give the preference of algebraic term. So if you will solve this one, so this will give you x naught to x. We will keep this minus s ds as it is, and we will try to integrate the other term. So this will give you e to the power minus s, and this 1 by s square give you minus 1 by s x naught to x. Negative sign will become positive, and this c2 is out of the whole bracket. So this will be e to the power minus s, and since this is minus s, x naught to x dx. Observe from here, these two factors will be cancel out, and you will get to only e to the power minus x divided by x minus e to the power minus x naught divided by x naught. So if you will solve this one, c2 e to the power minus x divided by x minus x naught divided by x. Still it is not fully solved. We need to multiply it with Wronskian at x naught, that is some constant, and y1x, and with this answer. So our y2x will be multiply this with one Wronskian at x naught, and y1x was x. c2 into the power minus x divided by x. Here again when becomes positive. Okay. Minus into the c2. So this will give you some w x naught c2. This is some constant the power x minus w at x naught e to the power x naught divided by x naught c2. This is whole constant x. X was our first solution, and this is the another linear independent solution. So we can ignore this one. Our y2x will be nothing but e to the power x. I'm just writing exactly e to the power x. Here it is a constant, so it can be any multiple of this. So in general, and you were aware about there was one solution x. So in general, what you can say, in general we can say that any linear combination of this y1 y2, that is c1x plus c2 e to the power x, is the general solution of the given differential equation. Or if in other word I would like to write, I can say that in other word I can say that is x and e to the power x is the Li are the alike solution of differential equation. And as I told you earlier, this differential equation is of second order, so it has only two linearly independent solutions. So for your practice, I am giving you one more question that is quite similar to this approach that we mentioned here. Find general solution of second order equation x y double dash minus 2x plus 1 y dash plus x plus 1 y is equal to 0, knowing that an exponential function is solution. So we know that it has a solution as an exponential function. So you need to first guess that solution, and with the help of that solution and the Wronskian, we have to find out this it's another solution. Try this one. So are you to find out this first solution? So let us go with the simplest one. We'll first try simply y-x is equal to the y1x to be e to the power x. Let e to the power x. So this derivative again e to the power x. Same is the so we will put left side minus x plus 1 x plus 1. If you solve it, this will give 0. This RHS. So that means y1x is equal to e to the power x is a solution of this given differential equation. So y1x is independent solution. Sure. So here we should also write is independent rather than the. So next is we need to guess y2. Again I am writing the formula of y2. This was w naught x y1 x integration x naught to x 1 by y1 s whole square e to the power minus x naught to s p p p. Okay, so we need to first write this equation into this particular form. So for that, y double dash minus 2x plus 1 divided by xy dash plus x plus 1 divided by xy is equal to 0, where x cannot be 0. Therefore, this first factor x naught to s pt pt will be e to the power x naught to s 2 plus 1 by t pt. Since it has a negative sign, so I sign. So this will give you 2t plus ln mod of t from x naught to s. This will be e to the power 2s plus ln s, and the other thing I am treating as constant. So this will give c2, here c2 is e to the power c1, and the other factor will be s times e to the power 2s. I hope till now it is clear. Okay. Then the other thing is y2x y2x is equal to w at x naught. So my this w naught x is a notation which means w at x naught, okay, into e to the power x integration from x naught to x 1 by y1 s square. Y1 s is e to the power s, so it will be e to the power 2s, and this integration has been came out to c2 times s e to the power 2s ds. So this will be c times w at x naught e to the power x, e to the power 2s will be cancel out. This will be s square by 2 from x naught to x. So this will give you c w x naught x square e to the power x minus c times w x naught square e to the power x. So we were aware about that e to the power x is one of the solution. Therefore, another solution will be y2x will be should be independent of this e to the power x. So this will be x square. So in general, what will be the general solution? Yx will be c1 e to the power x plus c2 x square e to the power x. This will be general solution of given differential equation. Okay, or in the another way, e to the power x and x square e to the power x is the set of Li solutions of the given differential equation. So till now we have done the illustration over non-exact equation, linear in general, linear ordinary differential equation, or you can say Bernoulli equation, and we have defined the Wronskian and see some property of the Wronskian. And now we have done the question over this with the help of Wronskian, and the first solution is known, or you can hit and trial. Then how can you get the second solution? Now the simplest one is, what if we have given that in second order ODE we have given the simply constant coefficient? What will be the case in that scenario? So for that I'm writing a question number 9. Find general solution of y double dash minus 3y plus 0. So the approach for this question is the valid for even nth order differential equation with constant coefficient. So I'm giving you the hint that you may proceed with trying that the solution of this differential equation is some e to the power lambda x, and try to put the value, try to make it satisfy in this equation and find out the value of lambda, and then you get to know the what will be the solution of this differential equation. Try this one. So as I told you that proceed with the assuming that the solution has form e to the power lambda x. So let ix e to the be solution differential equation. So then phi dash x will be lambda e to the lambda x by w dash x will be. So if you will put into the equation, this will be lambda square power minus 3 lambda plus 2 times e to the power lambda 0. So if you will take out e to the power lambda from this equation, it will align. Now it is obvious that e to the power lambda is not 0 for any x. Therefore, what has to be 0 is lambda square minus 3 lambda 2 0. It's a quadratic equation, you know how to solve it. So minus 2 lambda minus lambda 2 is equal to 0. This will give you lambda minus 2 and lambda plus 1. So lambda has two values, minus 1 and 2. So we know that is, we are assuming that e to the power lambda x is a solution. That means e to the power minus x and e to the power 2x. This is the Li solutions. So if you will write in the form of yx, so c1 times e to the power minus x plus c2 times e to the power x is general solution. So now you learn how to solve this second order ODE with constant coefficient. Now what if I would change a little to this to IVP, that is initial value problem. So find solution of IVP by double minus 2y dash plus 3y0 and y0 is 0 is 4 by this one. In the same way, you have to follow that into the power lambda x solution. Then you have to uh, find out the general solution, and with the value of these initial values, you need to conclude what is your particular solution. Since we have given the initial values, then the solution, the arbitrary constant will be removed, so it become particular solution. Try this. This solution is a little different with this one. Again, we will assume that e to the power lambda x is the solution, and that y double dash will be lambda square e to the power lambda x, and y dash will be lambda e to the power lambda x, and y will be e to the power. So, and we will prove, we will assume we'll get to this stage. So I'm directly writing lambda square minus 2 lambda plus 3 is equal to 0. Now, if you will observe that it will have imaginary roots. So 2 plus minus 4 minus 12 divided by 2, which will give you 1 plus minus under root 2 pi. Okay, so we know that our solution is e to the power lambda x type form. So our yx will be c1 e to the power 1 plus under root iota this whole time x, c2 e to the power under iota. So if you will rewrite it, it will to the power x c1 times e to the power under root 2 I x is nothing but cos under root 2 x plus I times c1 sine under root x plus here it will be c1 cos, so c2 x minus I times c2 sine under root x. So this will give you some another constant. You can say if you will combine it, it will be c1 plus c2 and iota c1 minus iota c2. This will be some c3 cos under root 2x plus c4 sine under root 2x. Now you got the general solution. So since you have given the initial value problem, initial condition, so you have to find out its value. So you know that y0 is 1. So that means e to the power 0, and first factor will be c3 into 1, second factor will be c4 into 0. So it will nothing but 0, which will be equal. So this will imply that c3 is okay. Another condition is y dash 0 is 4. So what is y dash x from here? Y dash x will be e to the power x, this c3 cos under root 2x plus c4 sine under root 2x plus e to the power x minus under root times c3 sine under root 2x plus under root times c4 cos under root x. So this will be your another y dash derivative. And what will be y dash at 0? This will be c3 plus under root 2c, and this value is 4, and c3 is 1 under root 2 c4. So c4 will come out to be 3 by under root. Hence your final solution or particular solution of this will be to the power x cos under root 2x plus 3 by under root sine under root x. This will be a particular solution. So this will be the whole lecture from my side. If you have any doubt, any query, kindly ask. Otherwise, we will end the meeting.
Thank you, sir, for the class.
Okay. So since it is clear to everybody, so that's all for today's lecture. I We will meet on Friday at the same time, 6 to 8. That will be third week duration of this lecture. Week 3 lectures. Okay. Till then, bye.